All right, let's get into it. Have you ever really stopped and wondered how a computer program, say one written in Java, actually remembers anything? I mean, from a simple number to a super complex user profile, all of that stuff has to be stored somewhere, right? Well, it's a pretty fundamental question, and the answer, at least in Java, is really fascinating. Turns out there isn't just one single way to hold on to information. Nope. There are actually two totally different strategies going on, and getting your head around them is pretty much the key to unlocking how Java really works under the hood. So here they are, our two core concepts. On one side, you can store the actual direct value itself. Think of it as holding something tangible right in your hand. But on the other side, you can store a reference, which is basically just a pointer or an address that tells you where to find the real value. It's the difference between having the thing and having a map that leads you to the thing. Now, to make this perfectly clear, we're going to use a really simple analogy. Just imagine we're dealing with one of two things, either cash you have in your wallet or a key to a safe deposit box. This one little idea is going to guide us through the whole rest of this explainer. So yeah, before we dive back into any code, let's just strip this all down to its simplest form. Forget the jargon for a minute. For the next few slides, we are just talking about money and keys. Simple, right? First up, we've got what are called primitive types. This is the cache. If you have a variable that's a primitive type, it holds the actual value directly. It's simple, it's fast, and there's no confusion about it. If the variable says it has 20, it has exactly 20 right there. The value is right there with you. And that brings us to the other side of the coin, non-primitive types, which you'll also hear called reference types. This is our key. Now, the key itself isn't the treasure, is it? Of course not. It's just a piece of metal. But it holds immense power because it gives you access to the safe deposit box where all the valuable stuff is actually stored. The key is just a reference that points to the real object. All right, so let's take our key and head on down to the vault. It's time to see what kinds of safe deposit boxes, or, non-primitive types, we can actually work with in Java. This is where things start to get really powerful. So inside our vault, we find four main types of boxes. We've got strings, which hold text. We have arrays, which are for lists of items. We have classes, which let us build our own custom objects from scratch. And we have interfaces, which kind of act like rule books for those objects. Let's open each one up and take a quick look. Our first box is for strings. A string variable itself isn't the note with the words on it, it's the key that lets you open the box and read that sequence of characters inside. And this, by the way, is why strings in Java are what we call immutable. You can't just go and change the note inside the box. You can only get a key to a brand new box that has a new note inside. Okay, now imagine not just one box, but a whole row of them all connected together. That's pretty much what an array is. It's the key that opens this entire row, letting you store, access multiple items of the same kind, like a collection of gold coins, each in its own numbered slot. Just be aware, though, the length of that row of boxes is fixed the moment it's created. Now we get to classes, and this is a really, really crucial distinction. A class is not the box. A class is the master blueprint that you use to build the boxes. You design everything about the box first, what kind of data it holds, its fields, and what it can do, its methods. Then, you use that class blueprint to create as many actual objects or boxes as you need. So if a class is the blueprint, you can think of an interface as the bank's set of regulations. It's a contract. It basically says, hey, any blueprint for a safe deposit box that you design must include a specific type of lock, and it must have a defined way to be opened. It doesn't build the box itself, it just defines the set of rules that any blueprint has to follow. That's what ensures different types of objects can be used in the same way. Okay, so we've seen the cache, and we've toured the vault of keys. But why does any of this actually matter in practice? Let's bring it all back together and see why this distinction is one of the most powerful and practical concepts in all of programming. So let's really break down the core differences here. Primitives are cache. They store the actual value. They live in a special part of memory called the stack, which is incredibly fast and efficient for these simple fixed-size values. But non-primitives are keys. They're different. The key itself, the reference, that lives on the fast stack. But the much larger variable-sized box, the object, that lives in a more flexible area of memory called the heap. So the bottom line is this. Primitives give you speed and simplicity for basic data. But non-primitives, they give you the keys to the kingdom. They allow you to build and manage these incredibly complex, powerful structures of information, which is what modern software is all about. This whole stack versus heap thing is exactly why passing an int to a method is so different from passing an array. With one, you're copying the cache, but with the other, you're just copying the key.
See, understanding this difference isn't just some academic thing. It's about knowing when you need simple cache and when you need the key to a vault. You now have the blueprints. The real question is, what are you going to build?